Welcome to another episode of Complete Developer Podcast, the podcast by coders for coders about all aspects of creating your best life as a developer.
I'm Will, the accomplished developer, author, and software architect.
And I'm Beej, the journeyman developer sharing my journey in development.
Complete Developer Podcast is supported by listeners like you. We are now on Patreon at www.patreon.com/Complete Developer Podcast.
Git is a version control system that allows developers to collaborate on projects, keep track of changes, and easily revert to previous versions if necessary. It's an essential tool for any software developer, but if you're new to Git, it can seem overwhelming. In this episode, we're going to cover the basics of Git, including what it is, how it works, and some basics on how you can use it effectively. But before we get started, Will, what's been getting you lately?
Getting me?
Yeah, I don't know.
Honestly, things are really, other than the obvious news items, there's not a whole lot going on right now. It's just sort of a calm period in life. We've had several big storms come through and then obvious other stuff in the news, and I don't know, just trying to chill out right now more than anything, because it seems like everything is set to wire you up.
Yeah, man.
So
I get that.
Yeah. So how about you?
I headed down to the Atlanta Cloud Conference this past weekend. Posted some photos on our Instagram about that. And so if you follow us there, I think I also posted them on Facebook.
You did?
Okay, good. I'm glad. So posted some photos. I was hanging out in the speaker lounge before my talk, just going over stuff, making sure like I had it down, even though I've given it a handful of times. And everyone was using ChatGPT. Every speaker in there, except for me, because I already had my talk written, but they were all using ChatGPT to write sections of their talk. A lot of them were using it for the demo portions.
Yeah.
They're like, write code that does this, write code that does that, or give me 4 examples of this in a hierarchy of difficulty. And Sven was saying, his was like, he's like, all but the third one are really good. So he just told it, hey, rewrite that third one. And it did. He's like, well, that'll work. And we were joking about how someone said they had found a video where someone took the printout from ChatGPT and had a text reader read it in like some actor's voice. I forget which one. There's several actors that have really cool voices. Yeah. And so we were all joking about that. And they're like, what's the point of even being a speaker with ChatGPT? And like, I was like, so you can pronounce the word lead correctly. Because that was the way that he knew that it was like off, as it pronounced it like lead. Because it's like one of those, can you tell this isn't a person? And I was like, it's so that we can pronounce the words correctly. And then Sven was like, well, they probably should have gotten a native English speaker for that.
Yeah.
I don't know. It was fun, and it was hilarious that everybody was using it. Like, it wasn't a secret or anything. I guess it was like the secret that everybody knows. But yeah, everyone was using it to get material. No one was using it to write their entire talk like we did a few weeks ago on that one episode. But they were using it for different sections. Like, I used it to look stuff up for this and to get some ideas for it. So yeah. Anyway, I just think it's really cool how many people are using ChatGPT. And like Chris said in the episode, it's so cool to be around for this major change.
Yeah, for real. That's the real interesting part, is just wondering where it's going to go.
Yeah, man. It really is. Speaking of where it's going to go.
Saving money is hard. It's just hard.
Straight up, dude. Especially with tax season coming up.
Real.
Here in the US, at least. I don't know about other countries. And speaking of tax season, Lucas Casares is a fee-only certified financial planner. He owns and runs Level Up Financial Planning virtually out of Fort Collins, Colorado. And he also does taxes.
Oh, I didn't know that.
Mm-hmm.
And just like us at Complete Developer Podcast, he focuses on helping you to not only establish a real plan, but also to take action on that plan so that you can live your best life.
Investing in financial planning services, it really comes down to whether or not you can improve your finances. With the help of Level Up, the compounding impact of making better financial decisions will easily pay for itself.
Level Up also has a unique pricing model that will help you no matter where you are in your financial journey.
And best of all, Lucas is a fiduciary for his clients. What that means is he's not here to sell you a product, but to help guide you to a better financial solution.
And you can catch his podcast, Techie Personal Finance Boot Camp, where he covers financial topics that you probably face. And he also interviews other IT professionals who share how they navigated their own careers. And you can learn even more at levelupfinancialplanning.com.
Git is a powerful tool that is essential to software development process. It was created by Linus Torvalds in 2005 as a way to manage the development of the Linux kernel. Today, it's widely used by developers all over the world to manage their own projects and collaborate with others. Git has become the industry standard for version control. With Git, developers can easily keep track of changes, experiment with new ideas, and collaborate with others on the same project.
If you're new to Git, the terminology and commands can seem overwhelming. However, Git is well worth the time and effort to learn. In fact, you're pretty much going to have to learn it if you're doing software development. Thankfully, you only need to learn a few things to get started. With Git, you can keep track of all the changes you make to your code, experiment with new features without worrying about breaking anything, and collaborate with others on the same code base. Git is also great for organizing your code and keeping it up to date. With Git, you can create branches for different features or experiments and then merge them back into the main code base when you're ready.
Learning Git is an investment in your future as a developer. It will not only make your life easier, but also make you a better collaborator. By using Git, you're able to work with others on projects more effectively, and you'll be able to contribute to open source projects more easily.
In this episode, we're going to discuss the basics of using Git to track your code. This is a high-level overview, as many of these points, such as branching strategies, effective use of Git, and best practices, could potentially be their own episodes and, frankly, are subject to some pretty strong opinion discussions. If you ever have had one of those.
Yeah, we could probably make an episode about almost every point in here, I think. It was not the easiest task to narrow it down to an overview, which is why having ChatGPT help me with that was nice. But also, when you feed it some information and say, hey, turn this into a paragraph or a 3-paragraph intro, it repeats itself a little bit. So just saying.
Well, I do that.
Yeah, I know you do.
Sorry.
Especially if you write one paragraph and then go away and come back and write the second paragraph.
Yep.
Yeah. So, all right. Starting off, how does Git work? Basically, Git uses snapshots to keep track of changes to your code. It kind of like takes a picture of your code as it is when you commit.
Yeah, and these snapshots are taken of the entire code base at specific points in time. Again, this is at a commit, and I don't think there's any other places where that occurs. There's probably some of the branching and merging type stuff that happens too, but stashing, that's the one I was thinking of. Okay. But Git will store these as commits, which can be thought of as kind of checkpoints in the development process. Developers can switch between different commits to view the code at different points in time.
Which is super useful if you're working with someone in the same code base on the same branch and they commit something or you commit something and it breaks. You can track it back and figure out what is going on. Yeah, committing is very important, and we're going to get into some more details about like the things you need to do with committing, like the messages and how to do that in just a little bit. Git also uses branches to allow developers to work on multiple versions of the code at the same time. So Will and I don't have to be working on the same code. We can work in the same code base, and I can have a branch. He can have a branch. And then we will each merge that back into our main branch.
Right. Which, by the way, we do need to fix that on the new podcast website code because I've just been pushing to master because I'm a scrub.
Yeah.
Because I've been the only one in there.
I am working on a project all by myself, and I am still using feature branching.
That's good.
Because I don't want to get into the habit of pushing straight to main all the time. So,
yeah, well, once you join the new site, start slinging code in there a bunch, obviously I'm going to have to be more disciplined. Right now, it's quick and dirty. So, because usually it's like, oh, I got 5 minutes to do this one thing, and I do it and I get it pushed up.
That's why I have the feature branches, because I can, I'll keep those branches. They're more long-term branches. So, yeah, no, I get that.
So Git also uses a staging area to allow developers to selectively choose which changes to include in a commit. So you can say, hey, don't put this in there. So sometimes you're going to have files that you don't necessarily want auto-staged. A great example of this is where you've got hard-coded constants. I actually ran into this today that are different between dev and production, and they haven't been factored out into an environment variable. And so you're having to change the code every time you switch branches because you pull from master and branch off of it, and it's got what's the production one is in there. So those kind of things, it's very handy. It's also somewhat handy at times if you're working on something and you have to kind of stop in the middle and just get a quick fix up from what you're working on, and then you're going to do the real fix. I've seen that quite a few times. I've done that quite a few times.
Yeah, I know. Sometimes I want to I'll work on 2 or 3 things that are all related, but I want to bundle. So I will add certain things to the staging area, commit the stage stuff, and then commit the other stuff in 2 separate commits so that I can have them separated out. That way, if I need to go back and look at things, I can follow my trail a little bit better.
I've also done that too when I've had multiple people who need to review the code. So for instance, if you're doing stuff on AWS and you really probably shouldn't be doing this, but in practice, this happens, right? Where you've got app code that you're touching and you've also got DevOps code that you're touching. You want to have separate commits for those 2 things, but when you're testing it on your local, you have to have both, or you're testing it in your test environment. You got to have both of those. Otherwise it's not going to work, but you want the commits separated out so that you can send somebody who's reviewing to one commit instead of the whole thing with parts they don't understand.
So next, we're going to talk about how to use Git effectively. Some kind of broad overall things. We're going to get more detailed into the Git commands after that. But we're going to start off with just sort of some overview of how to use it. And the first thing is use descriptive commit messages to make it easier to understand the changes made to the code base. This is very important. Just remember that your commit messages are only visible if you go in to look at the commit history. So we had this issue where someone who wasn't super familiar with the Git process went and made some changes, and it was just new to the person, but made some changes, put information like, oh, hey, while I was in here, I saw this and fixed, changed the wording of this in the Git commit for it, but not in the pull request or not in any other documentation. And so it wasn't a huge issue, but the product owner noticed and was like, hey, I didn't want the wording changed there. Why'd you guys change it? Nobody knew what was talking about because the person who had done it was actually out sick or out on vacation or something. I don't remember, but wasn't there that day. And had totally done it out of, hey, I think this is better wording. But what happened is it missed some of the things that were in there. And it was correcting a typo, but then changed the structure of the sentence so it didn't include certain things that were necessary. And that led to this whole, hey, let's not change things unless the PO approves it kind of stuff. But also, just because it's in the commit message doesn't mean that it's going to be seen when someone reviews the code, because they're not going through, we don't regularly go through and look at all the commit messages. I don't know about you. but I don't think that's a good practice.
Not very often. Some of the Git integration tools to IDEs will show them, which can be okay. You just got to be careful about what you put in those messages too, because you can't make the assumption that it's going to be seen. You also can't make the assumption that it is going to be unseen.
Right.
I know that was a problem. I want to say even in the Linux kernel, there were some pretty raw statements by Linus in there that ticked some people off.
I will say this person did a great job at the commit message. The message was concise, said exactly what happened. It was really well done, the message. It's just, that information should have been in a different place, not in the commit message. Should have been in the commit message and in the pull request. And so we just did a review on, hey, here's how we do our PR descriptions and stuff. And like we talk about every area that we touched and stuff. But yeah, you definitely want to be descriptive but concise with your commit messages because you don't want them to be too long.
Yeah, and that's why a lot of times it's like, hey, if you do over 50 characters, like, what are you doing? Which kind of feeds into the next point. Your commits should be small and focused on specific changes. The worst thing in the world is where you work with somebody that has one commit that touches like 1,000 files because it's their last 2 months of stuff. I worked with a guy that used to do that, and I can remember, was it at one point he hadn't committed in like a year and his hard drive died? Like he hadn't pushed up. I think he'd done like local commits or whatever, but it was always these huge blobs of stuff. And the company had to spend a lot of money to recover that. Plus, that code was running on client machines, the code that he had written. And, like he built it and built deploys out of it and it went out, but it was not in source control.
This is why I like a good CI/CD pipeline where it has to be in source control before it can be built.
Yeah.
And go out, like deployed. That's a whole nother topic, which maybe when we get to our refinement after this, we can discuss having an episode on that.
Yeah.
We're refining our backlog after we record tonight. So,
yep.
Anyway, next, use branches to isolate changes and prevent conflicts with other developers' code. And this can be really frustrating when you are making major changes, like upgrading to a new version or re-architecting some stuff because you realized, hey, what we had worked great for what it was, but now we're needing it to do more, so we need to change the way it's architected. I've had to do that before in the past, and it's really frustrating when other people are committing changes and you have to pull in their commits and then make it fit into there. That's when it becomes a race to see who can put out a PR the fastest, because if I can get my PR out before you, then you got to change yours to match mine. Yeah.
That's one good reason to keep your commits small, right? Is so that you can do that, so that, the people that have the worst habits are the ones that have the most pain, because that's how everybody gets better. You don't want the person with the best habits to suffer the most. You should also use pull requests to review changes before you merge them into the main branch and or potentially branches that other people are working on. So I've seen situations where you break out and you have a feature branch and then you have task branches with multiple people. Just basically any place where your code is going to slam into somebody else's code, there needs to be a PR. Or if it's going to slam into production.
Oh, yeah, definitely. Definitely for that. And then also you can use Git commands like git diff and git log to review changes and track progress. A lot of times your IDEs will have this built in, or if you use GitHub Desktop, that'll be built into. But it's a good idea to know some of these commands, which is what we're going to talk about next, the common Git commands. These are the ones that you need to know, even if you are using an IDE. So Git was originally written with a command line interface, CLI, to access the commands within it. Like, it was designed to be a command line interface.
Yeah, and while it is built into a lot of IDEs, GitHub even has a GUI, etc., understanding the basic commands and how it works is going to put you ahead of those people who just use the GUI. Yeah, in fact, a lot of times you're going to find that you have to use the commands to get around something. I frequently have to get around Husky pre-commit hooks where they're doing some kind of like trying to do linting on the code and all this stuff, and you're pushing something up so somebody else can pull it down and you can pair on it. because you're having a problem. And it's like, oh, I'm not going to let you commit, which I don't think that should ever happen. I get it if it's it's getting merged in somewhere, but I should be able to push up to a server. Nothing gets in the way of that. Like that drives me up the wall, just as a little Gantt rant, because what that tells me is, hey, there's something going wrong on my machine and I need to get my code off of there so I don't lose it. But now I've got to clean up crap. Or I'm heading out on vacation. I got as much done as I could. I'm handing this off, or, I'm going to the hospital for a loved one who's dying. You just got to think about that workflow a little bit. And I really hate Husky pre-commit hooks because this job and the previous one both, that was a headache constantly.
That's ridiculous because when you do a pull request, like that's where we have our linter, like it checks all that is at the PR level.
I love having the linter locally. I love being able to run it before I push it up. That's fine. But like when I have to fight with the linter, when I'm trying to do something like, hey, I just need to put a console log here to see, so that I can let it run and see what the output is as it changes over time. It's like, no, you've got to go and disable blah, blah, blah on the file. I'm like, come on, that has nothing to do with what I'm doing. And what ends up happening is you put that there and you forget it and you introduce a whole bunch of other problems. And, it's like, hey, I get it. Put the angry squiggles under it by all means to a point. I've also seen linters like decide that the entire function is bad because it's got an underscore at the beginning of the name or something, or it's got the wrong carriage return line feed or whatever. You can get me into a rant mode real quick on linters. They irritate me a lot of times.
Oh yeah. And some of the ones for VS Code will like throw a conniption about modules for Angular when it's like, that's a runtime thing, not a compile time. And like, it's there at runtime. It works.
So let's talk about some common Git commands that you're going to need to know to use the CLI effectively. And probably the most important of these is git help. That's GIT space help. It gives a list of Git commands, and you can also pass a command into it, by adding -- command to get info about that particular command. So when you're trying to turn off the stupid Husky pre-commit hooks, you do git help -- commit or it'd be -- commit, and it'll tell you how to use the -- no verify flag.
Yeah. What Will didn't say is I zero indexed this list so that it would because we don't normally do that. We normally start with one, but I did that on purpose here because git help is, if you know none of the rest of these, it's going to be the thing that gets you through. Like this is the one thing that you have to know before any of the rest of these commands, because if you just put in git help, you'll get a list of commands and then you can follow that and figure out what you need. So if you only get one thing out of this episode, get help.
Don't be a bully. Get help.
I'm sorry. I wasn't even trying to be punny there. I was just like, GIT help. Get help is going to be like a lifesaver. I do remember those commercials.
Yeah, because you're old.
The next one is git init. It also worked out that number one is git init. So I thought that was funny too. But, and this initializes a new Git repository. So if you're not cloning something down from GitHub or your repo depot of choice.
Okay.
You like it? I just made that up, man.
Yeah. That's poetry.
Repo depot.
Yeah.
That needs to be another t-shirt. Repo depot.
Yeah. So once you've initialized your local Git repository, git add will add changes to the staging area. So if you touch a file or you create a file, I end up using the touch command on the console a lot to create a new file. And I don't really know why I do that because I don't know that it's necessarily easier. But when you actually want to add it to the repo, you have to do git add and the file name, or git add dot to add everything.
Or git add -a or -- all.
Yeah.
We'll add all the changes, basically, the files that have been touched.
Right.
So, yeah. The next is git commit. So once you've added these to your staging area, this creates a new commit with the changes in the staging area. Now, within this, a very important thing is -m or dash dash message, and that is your commit message because you need to have one.
Yeah.
Like, you're going to frustrate lots of people if you don't.
Well, and it may not even get in because a lot of them will not allow it.
Yeah, depending on where you're committing to. But yeah, so just -m and then your quotation marks to write in your message, and keep it under 50 characters, y'all.
Yeah. Another favorite of mine is Get Status. That shows the status of the working directory, so you can see all the changes that have been made. That is really handy when you come back in from a weekend and you're like, what was I doing Friday? If you didn't commit and push, that can kind of recover. It can also help you check to make sure that you didn't change anything that you didn't realize you changed. So things like app settings, you may have files for your IDE configuration that are getting checked in that you don't realize are getting checked in. This is how you catch those sort of things before a PR reviewer gets it, which happens all the time to me because I don't actually look for that. But if I was a better person, then it would happen. So, Beach, you'll have to do that.
Oh, so you're saying I'm a better person than you?
No, I'm saying you aspire.
Oh, I do. I do have aspirations. Try. Yeah.
Yeah, there you go.
So the next two kind of go together. The first one is Git branch. And so this shows you all the available branches in your repo.
Right. To be clear on that, if you have a remote, it's not going to necessarily show you all the ones that are remote. You may have to do a fetch between there.
Yeah.
Which wasn't on this list, but that,
That's true. I use git fetch all the time. I didn't even think about git fetch.
Yeah. I wouldn't have thought of it either.
Git fetch updates your local repositories from that and gets back updates your git as well. Your .git file with the new branches too. So, but git branch shows the available branches. Then git checkout is how you switch branches. So you can do git branch, see which branch you're on, find the branch that you want so you know the name, and then git checkout and type in the branch name.
Git merge will merge changes from one branch into another. I use this a lot when I have a task branch that I need to merge into a feature branch, or potentially I try to get somebody else's changes in. So I pulled the feature branch down, got the latest on it, switched back to my task branch, and then I merged the feature branch in. And then I could deal with whatever consequences, and it's just in my task branch.
That makes sense. Yeah, I use that similar path, but pulling down our main version branch to because we don't do feature branches, we do story branches. And so it's sort of more like a task branch, so to speak, but it's like all the tasks within that story are done that way. So, and we'll get into branching strategies in just a little bit. The next one is git pull, and this fetches and merges changes from the remote repository. So let's say that Will and I were working on the same branch. Like, we had done some pair programming, and like Will was helping me. He had been doing the coding, and I was watching. Well, he pushes his up. I can then do a git pull, and it will pull the changes that he pushed up down to my local.
Right. That merge that happens on there too is something to be aware of. Because if you got changes open and you're like, oh, I'm going to pull, you may have done something that's going to give you a merge conflict just on the spot. That one gets you a lot if people are working on the same branch on things that are too closely related. And then obviously the final one is git push, which pushes changes to a remote repository, unless you're behind what's already in that repository, in which case you got to go back and do a pull. You'll get a warning.
All right. The next we have is the collaborating with Git. So working together, we've kind of hinted at a lot of this throughout the episodes so far because there's just a lot of collaboration here, but it's designed for collaboration and can be used by individuals. I use Git myself for personal projects and still use a particular branching strategy that I prefer. I have my preferred branching strategy. How's that sound?
Sure. The collaborative nature of Git allows for multiple people to work on the same code base at the same time without interfering with each other's work much.
Yeah.
It controls the interference is basically what it's doing.
Well, I mean, it provides an interface for the interference.
Right.
There's a lot of tongue twisters in this episode.
So Git is actually a response to older source control systems that tried to prevent the interference completely. So you had a checkout mechanism with older stuff where it was like, I own this file for the time I'm working on it. Nobody else can touch it. If I go to Hawaii for 3 weeks and my plane crashes in the ocean, that file's still checked out. You're stuck on a desert island with Wilson and all that, and you come back, you got to put that file back in. That was a bad old system. And there's a reason things are done this way, because it was trying to stop a problem that was going to occur no matter what. And when you do that, you end up with all these weird hacks and stupid things going on. And so Git was basically like, hey, let's contain the problem, but not get rid of it.
When you said that, I immediately thought of the song Dirty Old Town. But yeah, no, that makes sense. Git enables version control, which makes it easier to track changes to code and roll back to previous versions if necessary. And this is really useful. We just had to do this because we'd started working on a new feature, and our product owner decided, hey, based on user feedback, we want to hold that new feature off until the next production push because I want to make some changes to it. And so we had to roll that back. And that was fun. I didn't have to do it. The developer who wrote that did, and he did a great job with it. But yeah, we had to roll that back. So yeah.
Collaboration with Git can be done using a wide variety of tools such as GitHub, GitLab, Bitbucket. On my local network, I've got Gitia. It's like super light, whereas GitLab is kind of a pig. GitLab will take like 4 gigs of RAM on the NAS, which is half the RAM.
That's a lot of RAM for...
It does builds and all the other stuff. But yeah, I put Gitia on there, and I don't know how much it uses. I just know it's not much. It's not enough that I've seen it, when you're trying to look at the top abusers of things.
Yeah. I do that.
Yeah.
Chrome.
Uh-huh.
Yeah. It's always Chrome. Since I got off Windows, it's always Chrome.
Yeah.
So anyway,
even if you have a video editor running, like I'll have like Caden Live doing processing, and it's like, what's chewing up my RAM and CPU? Oh, it's Chrome. I'm like, I'm doing video encoding. No comment there. Actually, lots of comments.
All right. Oh, that was good. The next thing we're going to talk about is branching and merging. We've kind of talked a little bit about that, but we're going to go into some more detail into them. Git allows developers to work on multiple versions of the same code base simultaneously. We've said that several times. And how it does this is through a feature called branching, whereas Will and I can both be working on the same code base. He may have a branch for the feature he's working on, and I have a branch for the feature I'm working on.
Right. And basically, branching allows developers to isolate changes and experiment with new ideas without impacting the main code base. So if you're working on something and it's like, okay, this thing is not stable yet, and some bug comes in, hey, I can either stash this or commit locally, switch branches, do the other thing, and come back.
Mm-hmm. I've done that several times where I was working on something, bug came in. All right, pushed up the stuff I had done to that branch, hopped over to a different branch to fix the bug, and then came back to it. I did like 3 pull requests in one day doing that.
Yep.
Just because it was like a lot of small stuff. And I finished that. So all I had left that day was writing the unit tests. So it wasn't that big of an interruption. But yeah. Once a branch has been created and changes have been made, the changes can be merged back into the main code base using pull request, merge request. There's different terms for it. I remember I was late to one of the volunteering things I used to do on Monday nights. And the guy who organizes it is also a software developer. And I was like, sorry, I was late, man. I had a PR I had to finish up. And he literally thought that I was at the gym and doing a like personal record.
Yeah.
Because he started asking me questions about like how much I lift and stuff. I'm like, all right, this is kind of a weird turn, but okay. And then I finally figured out what was going on. He's like, they use the term merge request, and he is like, I've never even like thought about pull request as a term.
Yeah, I've always thought it was a really strange term because it's from your perspective, from the person initiating it, you're not pulling. You're like, I want to push the code somewhere because I'm behind it, making it move, not
You're requesting the pull.
right. And it took me forever to like go, oh, okay.
Yeah.
And it still bugs me a little bit. I feel like it's ambiguous and it'll probably eventually be replaced with something else that they'll probably call it something different at some point because they'll be like, hey, dude, this is weird. But so merging is the process of combining changes from one branch into another. This can be done automatically or manually, depending on the tool used and to varying degrees of automaticness. I don't know, because, sometimes it's like, hey, these two things, I can't merge them because they're not the same. And it can't find, where that stuff needs to go, and you'll have to manually touch it. I also know some developers who will never merge anything automatically, period, because they're just like, hey, that's one more check on bad code because I had to literally approve everything coming in. They very clearly have not worked with like some of the systems I've worked with that have got a lot of files all over the place, or they'd be over that.
Some small pull requests were like, I approved one earlier that was 3 files and 2 changes per file. Oh yeah, I could totally see doing that manually. But
a feature branch for a refactor to start introducing microservices, maybe not so much.
Yeah. Right. I mean, if they want to do it, give them a week.
Yeah.
Or 2.
Well, I mean, because it'll teach them a lesson real quick.
Yeah. All right. So we've hinted at this too. And that's the interesting thing. It's hard to break this down and not talk about stuff before we get to it because it's so kind of interrelated. But now we're going to go into branching strategies. So there are several different strategies that teams, individuals, whoever you've got can use to manage your code and the way that you branch.
Yeah, and you really need to choose the right branching strategy carefully because it depends on factors, like team size, project complexity, release frequency. I would also say your communication architecture, like how your team communicates, because if you've got 4 dudes in a room, that is vastly different than 2 dudes in one room and 2 dudes in India in an unknown configuration, right? Because, there's latency in those communications. And that very much affects, it's almost like, I forget what the law is now. There's the law that says that your code's structure will reflect the organization's communication structure. Well, your Git branching strategy is also going to reflect that.
Yeah. I know what you're talking about. I don't remember the name of the law, but yeah.
I mean, in some ways, your branching strategy is architecture as code to some degree.
And also your branching strategy is a communication style.
Yes.
It's how you're communicating the code back and forth. So yeah, I mean, that makes perfect sense. Also, it's important to have a clear branching strategy in place so that you avoid conflicts and ensure a smooth workflow for the development team. Because if you're doing a feature branch that then has task branches coming off of it, you don't want someone making a task branch off of main.
Right. I think it's really important to remember that this is not a royal bloodline. This is a communication system. Yeah. Although even though the merges might belie that, but feature branching is where you create branches for a specific feature or a set of changes. Story branching is a subset within Agile that creates branches for each story as it is built.
Yeah. And then task branches would be for each task. I haven't ever worked anywhere that did task branching. So when you mentioned, I was like, oh yeah, I forgot about task branching because it's not something that I've done.
Yeah. We did it in a continuously deployed environment. So there were a lot of cases where, we might have to push a database migration out first. And it might have to actually be out there so that automated stuff could run and catch stuff up before the rest of the work got out there. It was to mitigate that kind of stuff too. And so the feature branch got merged into master twice.
Yeah, it makes sense. The next strategy is release branching. This is creating a branch for a release version of the software. This is nice because you can have that. All right, here's a branch that everything going into this release has. And then you can branch off for other things from that.
And some of this also depends, obviously, on how your code gets released or whether you go, hey, I've got clients that are on different versions of it, and maybe I need to do bug fixes in multiple places. So you could also have a thing where you have multiple release branches, you do a bug fix, and you're merging it into different releases. I mean, you may have to do stuff like that. Git flow is a popular branching model that uses a specific branch structure for different stages of development, such as actual development, release, and hot fixes. I have used this before. It's been a while. I've found it reasonably pleasant.
Yeah, I haven't really used Git flow, but I could see it because most of the stuff I've done is building something new, not a big product that we're updating or maintaining. So I haven't really had a good opportunity to use that, but I can absolutely see how this would be, especially with the hot fixes, because we ran into some issues where some stuff we put out in not this past push, but our second push to production, there's some bugs, but they were like business level bugs. They weren't like, oh, hey, things aren't working the same way. It was things aren't working the same way, but they weren't broken. So our QA didn't catch it. It was when they started using it, they're like, hey, this isn't working the same way. And we were using, like, that was part of our business flow. And so we had to go in and make those like hot fixes for that. So that would have been very convenient to have that kind of a Git flow for that. So now all these strategies may be used in combination. We've already talked about that a little bit, like such as having a release branch and then having feature branches within that and task branches from your feature branches. So you have like if you're doing not a continuous deployment, but like a versioned system, you have like version 3. And then you've got 3 new features coming into that. So each of those has their own feature branch. And then you've got your task or story branches within those features. So yeah, so you can combine these into a structure that works best for your organization, your style.
Yeah. So speaking of style, there are some things that are kind of considered Git best practices. And the first of these is obviously to commit frequently, ideally after every significant change. And there's a couple of reasons for this. One is obviously you want to have a version that you can kind of push up. But the other thing that this helps with a lot is if you tend to really go hog wild on something and go, oh man, I wish I hadn't done that. Well, guess what? You can roll back to the last commit very easily. It helps you in your own development, especially if you tend to do large refactorings. This is your safety net on your local.
It really is. I've had to roll back several times, and it was so nice to be able to be very granular with that. And it helps you find, hey, that's where, because you might work on like a bunch of stuff and commit. And then you working on the API, I'll make several commits, and then I'll go and test it out, like connecting it to locally run UI and go, oh, something's not working here. It's running on, like all the tests are fine, but unit tests and integration testing is very different.
Yeah, it can also help when you're working disconnected. So like if you can't actually hit the database right now because, hey, you're in transit and you're working on something, you do those commits. And when you get into the office, you go, okay, now let's test it. And when something blows up, you've got smaller slices to look at and potentially roll back and do those kind of things. So I've had to do that before too.
Yeah. And what's going to make it possible for you to go back through those slices is to write very clear commit messages. And we've been harping on that one since the beginning of the episode because that is so important, is that you write clear and concise commit messages that explain the changes being made. And if you're following the first one there of frequent small commits, then your messages don't have to say a lot because you didn't do a lot each commit.
Yeah. And bear in mind, when you get further up, like if you're worried about the proliferation of these, there are techniques like, squash merges and those kind of things that get rid of a lot of this stuff when it's actually noise. But it's like, hey, you really only want to reduce this when it is worthy of being reduced. You should also use branching effectively to avoid conflicts and to keep the main code base clean. Like you always want a workable version in main that can go out to production. You're going to have some screw ups there where that's not going to happen, but you want those to be as limited as possible. And you also, the branching is also to keep team friction down. I worked at one company where we worked off of main. Wow, this was years and years ago. So it was Visual Source Safe times, I think, or Source Gear Vault. I forget which of the two it was. But the other half of the team was in a very distant time zone, such that I basically never talked to them. And the people on their side were really bad. You'd push code up and they would see a conflict and they go, oh, keep mine and throw his away. You don't want those kind of frictions happening because, then I'd pull it down and break all my stuff again. And you lose half a day because they just deleted your code. Well, if you had your own branch, there's some formal merge process that's happening there where it's like, no, dude, you are going to look at these changes and it's going to say that you did it and there's going to be a paper trail. And that actually keeps a lot of the bad actors at bay.
Yeah, it really does. So the last thing under best practices is it's a good idea to learn and use Git workflows like Gitflow or GitHub Flow to ensure that changes are made in a structured and organized way. I mean, we talked about Gitflow strategy, but yeah.
Yeah, and it's also important too to remember that if you do get a decent strategy, that's fine. And if it works for now, that's fine. And you can kind of fiddle with it later if you have to. It's like any other communication workflow. You use it until it stops working, then you fix it.
Well, yeah, like I was having a conversation today with one of the developers on the team with me, and he was asking me about upcoming code freeze because we're about to do another production push. And I was like, oh no, what you're working on now, because I was helping him out with some stuff. I was like, what you're working on now is going to go into the production push. So don't worry about the code freeze yet. And I told him, I said, we're actually about to record an episode on Git, like the basics of Git. And I was like, I'm actually thinking about talking to our architect about changing some of our strategies and going with more of a release branch. So like in development, we would have a release branch that we would commit to. That way, if let's say what we had to do or we had to roll back, or like while we're going through the process, like the change request process to push up to production, well, it only requires one developer to work on that. The other two on the team could be working on the next feature going into a different branch instead of having to wait until this is done to push up to main. So yeah. And then that way, if we've got that feature branch, if there are production bugs, we can just work within that and not have to worry about, oh, we got to turn off this feature. And it makes a lot of sense.
That also makes me think of another best practice is to try to avoid long-lived branches.
Yeah.
Because they hurt when you have to merge, something that's been out there 2 months with 5 developers working on it.
Yeah, that's painful. Yeah. So guys, Git is a powerful tool that allows developers to collaborate effectively and keep track of changes to their code base. By understanding the basics of Git, you can become more efficient and productive as a developer. Remember to use descriptive commit messages. We kind of harped on that. Keep commits small and focused. We harped on that too. And use branches and pull requests to collaborate effectively with other developers. We didn't harp on that as much. And if you're ever stuck, don't hesitate to use Git's built-in commands. My favorite is Git help, because it's going to give you the most information, but you can also use Git status, Git log, Git diff. They'll help you understand the state of your code base. That's pretty much all we got. We will catch y'all next week.
Stand by for Titanfall.
If you have a question or comment, please email us at neckbeards@completedeveloperpodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed through Creative Commons.
For references, show notes, and extra tips and insights, be sure to check out the website at completedeveloperpodcast.com. Help us make the show possible by supporting us on Patreon at patreon.com/completedeveloperpodcast. You'll get extras, including a weekly aftercast where we discuss the topic of the week and bonus material with some of our patrons.
You can also follow us on Twitter at CompleteDevPod, like our page on Facebook, and follow us on Instagram to keep up with news about the show. Join the conversation anytime via Slack by signing up at slack.completedevelopernetwork.com. Thanks for listening. See you next time.